Hi, Block 5. I'm so incredibly sorry for being gone 2 days in a row. I promise to make it up to you next week. Just thank you so much for being so great with the substitute and for going through these problems. So I really, really, really appreciate it. I'm just going to keep track of any work that you guys have done yesterday or the day before and today and give you guys points for that. If you're somebody that needs to make up quizzes from the past, from Chapter 6, we'll do all of that next week. Just keep checking Power School and I'll make sure that we do that next week. Okay, I'm very, very, very sorry. All right, so let's do the solution to this problem here. So when you're not given the normal looking problem like we have in our learning packets, the best thing we can do here is to create this piece on your own. So balance the reaction and then set up the have-want scenario like this on your own, and then the problem becomes a lot easier. So for example, in this problem, it said if 5 grams of methane reacts with 5 grams of oxygen, how many grams of carbon dioxide are produced? Who is the limiting reactant? So step 1, we're going to balance the reaction. Methane is C1, 1 times 2 is 2, plus 2 is 4. CH4, okay, and this is a combustion reaction. Anytime I use these words methane, ethane, propane, etc., it's always combustion. 2 products we produce are carbon dioxide and H2O. Is it easy? For Joe! 1, 1, foe, 2. Gotta slow down at the O's. So I got 2 here and 2 here, giving me 4. So I'm going to put a 2 here. No need to take a poo-poo. Okay. Now I'm going to do have, wants, and bubbles. So the first thing I have is 5 grams of methane. And the next thing I have is 5 grams of oxygen. And the thing I want is how many grams of CO2. Okay. So if we look at our flow chart, the first thing we're going to do is convert grams have to moles have. Then we're going to convert moles have to moles want. And then we're going to convert moles want to grams want. And there's a little line where it goes from blue to red here. So these are all 3 bubble problems. So let's set each one up. 5 grams of CH4 equals grams CO2. Notice I leave a little space here for my answer. And in this one, it's 5 grams of O2, 3 bubbles. And I leave a little space here for my answer. So this first bubble is the molar mass bubble. So what you got on the bottom, grams CH4, and what I want, moles on the top, moles CH4. Okay, so in 1 mole of CH4, there's 16 grams. And in this one, let's do this whole first one first. And in this next step, what I got, mole CH4, what I want, mole, whatever I'm going to, in this case is CO2. And in this step, it says use the mole ratio. So that's those big ass numbers from the balanced equation. So 1 here and 1 here. Okay, now what I got is moles CO2. See, I've done this step and I've done this step, so now what I want is grams CO2, and this is a molar mass step, but it's the reverse of this first bubble because now moles is on the bottom. So what I'm going to do to get the answer is I'm going to take 5 and I'm going to divide that by 16 and I'm going to multiply that by 44. And it's 13.75. And you know what I'm going to do is I'm just going to keep that at 1 digit because this doesn't have a decimal point here. So I'm just going to call that 14. Actually, probably isn't smart for me to circle that yet because I don't know who my limiting reactant is. Okay, in this one now, I'm going to put grams O2 on the bottom. In the first bubble, I want to go to moles, half moles O2. There's 32 grams of O2 in every 1 mole. It's common to put 16 here. People forget to multiply 2 because of that 2 there. Now moles O2 are going to go on the bottom, and I look in the next bubble, and I'm going to moles, but I'm crossing this line. So it's going to switch to moles CO2. In that step, I go to the mole ratio. So the big old number in front of CO2 is 1, and O2 is 2 in this case. So CO2 is 1 and O2 is 2. What I got goes on the bottom, CO2, and in this case what I want is gram CO2. But these last 3 little steps here are all going to be the same because we're going to the same thing. Okay. So what I'm going to do is clear this, and I'm going to put 5 divided by 32 divided by 2, down low divide, times foe to foe. And that's 3.375, but I'm going to round it down to 3. Okay, so now I look at both of these, and the one that produced the least amount is my limiting reactant. So this is the answer. And the question asks, who is the limiting reactant? Limiting reactant equals O2 because it produced less CO2. Okay. When you're looking at these bubbles, there's a lot of different ways to put in the right answers. One way that I came across when I was subbing Mr. Farrell's class last week is I looked at one trend I saw was that if the label here changes, so this is mole and this is gram, the chemical does not. So that stays CH4. But if you look at this middle bubble, the label doesn't change, but the chemical does. Okay, so because this is moles and moles, one of them CO2 and one of them CH4. Whereas this is moles and grams, so they both stay CH4. So there's a lot of different ways to do it. I would just go through the flow chart and go step by step. What you got on the bottom, what you want on the top. What you got on the bottom, what you want on the top. What you got on the bottom, what you want on the top. Okay, guys? So in summary, this problem doesn't make sense because oxygen would never be the limiting reactant, but the steps going through the problem are exactly the same. Okay, take care.